I'm Neil, and I will be solving number 6, A and B. This is a graph of velocity versus time graph, and it shows velocity versus time. However, the question is asking for the change in position. It doesn't give us the change in position because it only gives us the velocity and the time. To find the change in position, which is also known as the displacement, we have the equation, which is velocity is equal to delta x, which is the change in position, which we need to find, over delta t. The first question is asking to determine the change in position from the 2-second mark to the 3.5-second mark. That would be right here. Although it's a straight line, this is a velocity versus time graph, and it doesn't necessarily say the position. So to figure this out, we need to use this equation, velocity is equal to delta x over delta t, and plug in the values that we are given. From this velocity versus time graph, we can see that the velocity from 2 to 3.5 seconds is negative 40. So what we do is we put negative 40 in place of v. We set it equal to delta x, because it's just a variable that we need to solve for, over the time, which is delta t. The time in this case would be the difference between the 2 points, or the absolute value. So to find the difference between this point and this point, between 2 seconds and 3.5 seconds, you need to take 2 away from 3.5, which is obviously 1.5. I need to put the units over here, centimeters per second. From here, we use algebra to solve for delta x, or displacement, or change in position. So what we need to do is multiply both sides by 1.5 seconds. And we will end up with negative 40. Oh, wait. We will just do this in our head. Half of 40 is 20, so you add 20 to 40. Add the negative, it's negative 60 is equal to delta x. Therefore, the change in position is negative 60 centimeters. Always add the units. For part B, it says to determine the change in position from 5 seconds to 6 seconds. To do this, we use the same formula, except we change the values. The velocity here says it would be 20 centimeters per second, because it's at the 20 meter mark. So put in 20 centimeters per second. This is not negative, obviously, because it is on the positive side. We set it equal to delta x, the variable we were trying to find, over delta t, which in this case, 5 to 6, would be 1 second. From here, we do the same. We multiply both sides by 1, which is straightforward. Delta x is equal to 20. So the change in position is 20 centimeters.